Okay. Okay, we're telling you video. Let's see how this works. All right. Hello. Hopefully some of you are seeing me. Uh, this is really exciting and also a little terrifying. Welcome to my first Ask an Astronomer live stream. Oh, cool. We got some people joining. Great. Everyone's joining. Oh, good, good, good. Welcome, welcome. Good. I think there's people watching on YouTube and then there's people. Oh, hello. Hi. Oh, this is great. Got a lot of highs. I have not ever done a live Instagram thing before, so that is the most exciting aspect. I wonder if you can scroll back through. Maybe not. Maybe you can't. But I'm on YouTube as well and Instagram. Hi. Oh, hi, Anik. Oh, man, there's a lot of people I know. That's making me feel a lot better. So welcome to Southern Arizona. My name is Kevin. I'm an astronomer, as I said in many of the things, and as many of you already know. I might wait a couple minutes to get more people showing up. Oh my gosh, we got a bunch of cool people. Hi, Tyler. Welcome, welcome, welcome. Welcome to our bedroom. Laira's in the other room. She's got things she has to do right now. It's my wife. But there's a kitty here on the bed. This is Jeezy. Say hi to Jeezy, everyone. Hi, everyone. Hi. She might get up and wander around. Maybe she'll just go to sleep. She's a very cute cat. Hello. Oh, man, this is so exciting. Lots of waving. I'll get started in just a couple minutes. I want to make sure everyone gets a chance to join. And hopefully you're joining and maybe you have some people. Oh, hi. Hi, Laura. Hi, Brian. Hi, Anik. Hopefully some of you have people maybe who are curious about astronomy and that's why you're here. Not just that you know me, but that you're excited about astronomy and you have some astronomy questions in these trying times that you want to ask. So while people join, I'll just get going. So as I said, hopefully you guys can hear me all right on both Instagram and on YouTube. YouTube's up here, Instagram's down here. Oh, good. We're great. Great, great, great. So I'm an astronomer. I'm a doctor of astronomy, and I actually, as of a couple months ago, I'm a professor at the University of Arizona, which is where I work. I think space is awesome too, Ian. And I've been an astronomer my entire adult life, essentially. I thought I would take some time to answer some astronomy questions if people have them. Before I begin, let me tell you about what I do as an astronomer. And then hopefully that'll give you guys some things to think about. Maybe you can ask me about them. I'll have to say right off the bat, I don't know everything about astronomy. I know a lot, but I don't know everything. I mean, I think I know a lot. Actually, I probably know very, very little. To me, it's a lot, but maybe that's not saying much. And, oh, hi. Hi, Kisley and Angela. Oh, man, this is exciting. Oh, cool. I'm glad that people have their kids here as well. That's really exciting. I study galaxies, and I'll talk about what a galaxy is a little bit later, but I study faraway galaxies, and I study what are called things called black holes that you may have heard of. And so those are things that I really care about. And the reason that I care about it is because when I was a little kid, oh my gosh, look at all these fun people I know. It's so great. Hi, Georgia. When I was a little kid, I thought the only thing I could ever do with my life is either study dinosaurs or space. That's all I could ever do. I could not imagine doing anything else. And then I had to make a very hard decision and I chose space. And so now I study space, and it's been a really fun career. And I work here in Arizona on a space telescope. So maybe some of you out here have heard of the Hubble Space Telescope. It's a very famous space telescope, probably the most famous space telescope. And NASA and the European Space Agency and the Canadian Space Agency have worked together and have built the next generation of space telescope, which is called the James Webb Space Telescope. Oh my gosh, hello Lauren. I'm glad. Hi Olivia and Milo. And the next generation space telescope is called the James Webb Space Telescope, and it launches next year, and I work on that. I work on the main camera for that. And it's funny, I have so many cameras pointed to me right now, but I work on an infrared camera. And I could talk about that a little bit later as well. But essentially, what I do with my life is I get ready for this telescope, and I work with my colleagues, and I work with my graduate student, Raphael, and I work with people who are at my university and at other universities around the world, and we think about astronomy and we think about how we can do science, not just now with what we have, but what we'll have in the future with other future telescopes, okay? And if you don't know what a telescope is, well, it's kind of one of the main tools that astronomers use to look at the universe. Astronomers use telescopes, but they also use computers sometimes to simulate what the universe is like. And that's kind of what I've been doing in the last couple of years, because the telescope I work on hasn't launched yet. It's not in space yet. And so James Webb is going to launch next year. It's going to be really exciting. It has 4 cameras. I can talk all about James Webb because it's something I've thought a lot about. But yeah, so what I would like to do for this is I'd like to say if you have questions, you should put them in one of the 2 chats, and hopefully I'll go look and see and write and answer the questions. And so we'll just go there, and hopefully I can scroll back up and find questions and stuff. But for now, I see the first question, which is really exciting, which is Ian Tarago has asked, "What's your favorite thing about space?" That's a really good place to start. So my favorite thing about space is black holes. It's the thing I was realized when I was as a kid. When I was sitting and watching TV shows about science or reading books about science, I thought, what is a black hole? In fact, I have visuals. This is a book that my dad had. It's from 1985. It's a pop-up book. And it has a black hole in it. It's got a black hole. You ready to see the black hole? There's the black hole. What? And so you can see the black hole is represented by paper here. And it's going to be weird. You're wondering why you can see down the center. Well, that's just because it's black hole. That's how the paperback works. But this black hole, when I first heard it as a kid, I was just like, what is the black hole? How could I even, what could it possibly be? And the more that I learned about it, the more that I realized that what you think you know about black holes is not nearly as cool as what black holes actually are. So let's go back. What's a black hole? Big question. What's a black hole? And the thing is, black holes are what happens when you have a star that is incredibly big. I will definitely talk about red giants next, okay? And I'll talk about Mars. I love Mars. So there was this when stars die, and stars can range from stars that are smaller than our star, the sun, to ones that are hundreds of times as big, like massive as the sun. And when really massive stars die, they die because the insides of the stars can't keep them supported. And so what the insides of stars, generally there's stuff going on in the core that causes light to be made and pressure to hold it up against gravity wanting to pull it down. And so over time, when they die and that energy source in the center stops, the star will collapse. And when a star collapses, it pushes all of its material down farther and farther and farther and farther and farther until it's a tiny point. And we call that point a singularity. And if gravity is strong enough, then near that point, then not even light can leave that singularity. You have all that mass of a star compressed down to one single point. Gravity is so strong that you can't even leave. Like here, I've got this little Yoshi right here. If I take the Yoshi and throw him in the air, the Yoshi comes back down, right? But what if I took light, like a laser pointer, and shot it up in the air? Well, it would just keep going and hit the ceiling of my room here. But if gravity was stronger, it might come all the way back down because gravity was pulling it in. Gravity trapped it. And a black hole is an area of space where gravity is so strong it traps light. If someone says, hey, let's go hang out near a black hole, don't do it. Don't do it. That's my only advice that I give you. If someone says, let's go hang out near a black hole, bad idea. Both the YouTube audience, Instagram audience, no good. And the thing is that when you have something that's got this much gravity, things will fall in it. Over time, black holes will swallow material. And the material doesn't just fall in the black hole quietly. And this is when I learned this in grad school. It was just the coolest thing. Because it's being pulled in so strong by the gravity, the gas that's falling in or stars that are being ripped up by black holes, as it falls in, it doesn't just slide right in. It actually starts to make a big maelstrom of gas around it, a big disk of gas. And you can actually see that in this pop-up book here. You can see the disk of gas around it. It's hard to see, but it's all around it. That's what this is. It's a little ripped over here. But this is gas falling onto the black hole to make this maelstrom of gas around the black hole in the very center. And that maelstrom of gas, we call that an accretion disk. It's a big disk of gas. And the thing is, as the gas falls onto the black hole, as it goes onto that disk, it gets really, really hot and it starts to glow. And so when black holes that have material falling on them, they have disks around them that are glowing really hot. The black hole itself, if light gets in, it can't escape. But around it, in the neighborhood around the black hole, there's a big disk of gas that's glowing really bright. In fact, it's glowing brighter than almost anything. And the brightest things in the universe are these disks around black holes. We call them quasars. If you've ever heard of the word quasar, that is a black hole that is swallowing material right now in a disk that's so hot it can outshine the rest of the whole galaxy it lives in. Which is like if everyone in America started yelling and there was a P in Kansas, a little P in Kansas that was yelling louder than everyone else. It'd be a very loud P. And this is a tiny little black hole compared with the size of a galaxy. So this, when I heard this in grad school, I said, that's the coolest thing. And now I look for quasars. Thank you, Siri. So I study these types of objects, quasars. I try and find them throughout the universe because if you have something that's making that much light, it's got to be doing something to its galaxy. We can talk about that in the future. My next question, which gets right at the thing I was talking about, is from the friend who helped inspire this. And what I want to talk about is red giants. So I just talked about stars, right? I talked about big stars and how they die. Well, the thing is, stars go through lives, entire life cycles, just like we go through life cycles, where stars have young lives, and when they're young lives, they're in gas clouds, and the gas clouds make baby stars that all live together like a stellar nursery, or a stellar preschool, I guess, and it's clusters of stars. But over time, the stars are pulled apart from their clusters, and they live on their own, like our sun lives on its own in space. And so the thing is that when a star, like, gets to its kind of the main part of its life, it just takes what's like very simple stuff called hydrogen, the most simple thing in the whole universe. If you've ever seen one of those complicated periodic tables, it's up in the top left corner. It takes that simple hydrogen and turns it into the next simplest stuff, helium, which you guys know mostly because it's what we put in balloons at birthday parties. And the way that the universe makes helium mostly, besides being made in the Big Bang at the beginning of time, is that it just stars take, inside their cores, they take hydrogen and they squish it together to make helium, and it makes a little light. But eventually, over time, the star runs out of hydrogen to do that. It runs out of the material it needs to stay afloat. And so then it switches to the helium and says, I can take the helium and push it together and make carbon. That's pretty neat. So now you've got a bunch of carbon. And the thing is that over time, when it does this, a star will start to expand and contract a little bit and expand and contract a little bit because it's having to go through different types of fuel sources. And so a red giant is what happens when the star is later in its life and it's actually, the core is contracted and got so hot that the rest of the star is expanded and puffed out. And because it's puffed out so big, people who are watching on YouTube can see my full expanse of my hands here. On Instagram, sorry. I could probably do it this way. It's puffed out so big that the outer layers are cooler and it's red. Because in astronomy, if it's red, it's cool. If it's blue, it's really hot. In colors, when you're doing coloring, it's opposite. We say that things are blue or really cold. But in astronomy, blue, hot, hot, hot. Red, a little cooler. Still very hot, but a little cooler. And so this is a period of life, a red giant's a period of life where a star is really big and its surface is a little bit cooler and it may be leading up to the last stages of its life. The most famous red giant is a star named Betelgeuse. That's the first time I'm allowed to say it. Now this star, Betelgeuse, is in the constellation of Orion. It's the shoulder of Orion. If I say it 3 times, we get to all meet Michael Keaton. And that star is incredibly big. If we plopped it in our solar system, if we sat it where the sun is, it would not just be where the sun is, it would go all the way out so the Earth was inside it right now. And in fact, Mars would almost be inside it. Think about that. We're really far from the sun. Imagine one star that goes all the way out to where we are. That big. It's huge. And a couple months ago, astronomers noticed something really incredible about this star. What they noticed is that it was actually getting dimmer. And they were like, this is weird. Why is it getting dimmer? It shouldn't do this. We've been watching the star for a long time, and it's getting dimmer. And it got like dimmer by quite a bit, 2 to 3 times as dim, like really faint. And then like it started getting brighter again. And we took pictures of it. And it's one of the few stars where we can actually take a picture and see the star as like a disc. Most of them are little points. And barely see that like it had the bottom part was a little darker. And we were like, what's going on with this red giant? And it turns out that later in stars' lives, they start to get a little gassy. And, maybe for the adults out there, you recognize that this is just what happens to living things. And stars are living essentially in that they go through gassy periods where suddenly they can outflow dust and gas into space. And some of that was blocking our line of sight. So kind of like what my hand is doing right now. Imagine if I threw a bunch of dust out and it was dusty in the room. It'd be harder to see me. It'd be harder to see me for YouTube as well. And that was what was going on. This star, Betelgeuse, there you go, was actually outflowing dust and gas. You should look it up. There's a bunch of cool stories and pictures of it. It's really cool. All right. So that's what a red giant is. It's a part of a star's life. So let's look up some other questions. I think I heard what happens when you go through a black hole. So let's talk about what happens when you go through a black hole. We'll go right back to black holes. Most people want to know. So again, what did I tell you? What's my one bit of advice? Don't play near a black hole. But let's say you were playing near a black hole, which again is a bad idea. as you would fall towards the black hole here, you'd be pulled pretty hard, but your feet would be pulled harder than your head if you're going feet first towards the black hole. And if your feet are pulled harder than your head, then you start to get stretched. And we call this, and this is the fancy astronomy word, I'm not kidding, I'm not making this up, it's called spaghettification, because you're being spaghettified. This, in a fancy astronomy term, is called tidal forces, because you're being pulled by one side harder than the other. But you're actually being pulled, you're all going to fall in, but you're being stretched out. Now, and then as you fall in as well, you wouldn't notice any of this because it would happen so fast for you that you'd be ripped apart before you even had. But someone watching from far away would actually be able to observe that this was happening. And then on top of that, because black holes are so heavy with gravity, time would look like it was slowing down. Like, let's imagine you were wearing a big clock as you fell in. Well, that clock would get stretched and it would look like it was slowing down. Like, you'd be like someone far away watching and they'd be like, oh, this is bad. Why am I going into the blood? And it would look like time would slow all the way down to stop because time is weird. That's a whole Einstein thing. When you get into the black hole, most likely you're crushed into the singularity. We in science fiction talk a lot about how maybe what actually happens is, like in science fiction, you might go into a parallel universe. But the thing is we have no idea. And most likely, it's incredibly hard on the body to go through this. It would rip you apart. We couldn't build something that could survive a trip through a black hole. So right now, we just watch as entire stars or comets or objects in space, gas clouds, are ripped apart by black holes and they fuel the black hole. And we think that the gas probably stays in the black hole because we watch that black holes grow over time. There's a black hole in the center of our galaxy. That black hole is named Sagittarius A star because astronomers aren't allowed to be too creative. That's a very helpful thing for astronomers because we know what constellations it's in and it's also a radio source. But Sagittarius A star, or Sag A star, is millions of times more massive than our sun, which means it swallowed millions of suns worth of material. And that material went into the black hole and stayed there. So it didn't go anywhere after it went in there. It stayed right in there, and that's where it's sitting and helping the black hole grow. And so we see black holes that have millions or billions of times the amount of stuff in them. And that's what's pretty incredible. And so we think that when you go into a black hole, you don't get teleported anywhere else. You stay there and you're crushed. But in science fiction, a bunch of cool stuff happens. Like in the film Interstellar, you get to go back in time and talk to your daughter through a library, I guess. Yeah, it's neat. Cool. Okay. Let's see. I think there was another couple questions that I had up here. Oh, is gold related to stars? This is one of my absolute favorite stories. This is my wedding ring. It's silver. Everyone's silver with some turquoise and stuff. Silver and gold are in fact related to stars. So here's the thing. When the universe was born, it was born in something called the Big Bang. Here's the Big Bang. The Big Bang was an outpouring of energy into space. An incredible outpouring of energy, all as light. And that light, over time, slowly cooled down and formed very simple particles of a lot of hydrogen and helium I was talking about earlier, and maybe a little tiny bit of something called lithium, maybe a little tiny bit of something called beryllium, but mostly it's hydrogen and helium. That's what the universe made at the Big Bang. Those are the raw ingredients. And like, for those of you who are bakers, it's as if the universe in the very beginning just made flour and a tiny bit of sugar. And it was like, all right, make everything you can bake from those two things. And you can do a lot, but it might take some time, right? And the thing is that what happened was the universe needed ovens to take the hydrogen and turn it into heavier things. And so it needed stars. And there was a long period of time before the universe made stars and galaxies. And then when it made stars, those stars started putting together the building blocks in their cores, like I was saying, taking the hydrogen, making it helium, taking the helium, making it carbon. Now we got carbon. Why is carbon important? We're made of carbon. The stuff that your hands are made of right now. You can touch the stuff that was inside of stars because that's the only way the universe made you, was by taking stars as an oven and turning the simple building blocks of hydrogen and helium into you. And so then stars lived their lives and had those moments like what Betelgeuse did, where it was outgassing and that carbon moved off into space to form more complicated stars. But how do we get gold and silver? Gold and silver are elements on that same table I talked about, the periodic table, that are way, way, way down there because they're really heavy. How did the universe build those? Were they built in the centers of stars? No, it's even cooler. So, remember I was talking about the star that died to form a black hole? What if that star actually died and wasn't big enough to form a black hole? If it wasn't big enough to form a black hole, it would form something called a neutron star, which is like if you took an object that was the size of like Los Angeles or Chicago in space, like take Chicago, put it in space, or Los Angeles, put it in space, and get it spinning like 1,000 times a second. These neutron stars spin really fast because as they collapse, they're like an ice skater who brings their arms in and starts spinning as they're like, I guess I could do this, but I'll wrap myself in my cord. You know, like you spin and they go faster. And the thing is that the stars do that and they spin really fast and have taken and turned into a neutron star or into heavy elements. So it takes, I'm worried that maybe my thing might have lost connection there for a second. But anyway, in diamond is just in the Earth, carbon, the simplest carbon that we're made of, just pushed together over time to make a diamond crystal. Pretty cool. But to make gold or silver, you have to have two stars living their lives out and dying and colliding with each other over a long period of time and exploding and then sending out the gold and silver into the universe, which is very cool. Okay, my next question, Rob said we're universe carbon cookies, and that is exactly it. The universe is an oven that just takes light and says like, let's just see what happens, and then slowly bakes us into carbon and nitrogen cookies, and a little hydrogen and oxygen as well. Thank goodness for that. All of them come from stars. So Eleanor says that they want to know what my favorite constellation is, and is there a story behind it? So yes, and I pulled these out just in case someone asked, although I don't know if I can, actually here, I pull out, so I'm gonna make a recommendation. You guys are all, maybe some of you are in a spot where you might be like living in your house right now and staying in your house right now. But if you go out at night, hopefully, as long as you're not like in downtown of a major city, you can see some stars. And so if you want to go out and start learning the stars, this is a pretty good time to do so. And this is the book that I recommend. I love this book. I have many, many copies of this book. This is the paperback. This is my hardcover. My hardcover has seen better days, but I love it. It's called The Stars. It's by H.A. Rey, who did Curious George. And The Stars is a book that has like a bunch of constellations. All the constellations are redrawn here to look like what they're actually supposed to be. So this is my favorite constellation. This right here is Ursa Major. Ursa Major means Great Bear. And I bet you've never looked at Ursa Major picture and said, oh, that looks like a bear. But that looks like a bear. Look, the bear's looking up. There's a bear's little back, the back paws, the front paws. This is Ursa Major. Ursa Major is by far my favorite constellation. And it's a constellation you can see almost all the time. In fact, right now, right after sunset, Ursa Major will be towards the north. You'll be able to see, just look to the right of north. Now, how you find north? Well, we have phones that allow you to do that. Or you can look on a map, or you can just look around and hopefully find Ursa Major, because that's what I look for when I want to know where north is. And why is it my favorite constellation? Because it's where I base all of my looking at the stars. I start by looking at Ursa Major, the Great Bear. Ursa Major also contains the Big Dipper, and I'm going to try and show you this, but it's going to be hard. I have freckles of the Big Dipper on my arm here. You probably can't see them, but you can see some freckles. But I have freckles here. I have some freckles up here that are Ursa Major on my arm, at least the Big Dipper. And the Big Dipper is one of the most ancient constellations. People around the world look to it. In ancient Egypt, they called it Meshkatiyu, which stands for the bull's leg. People have names for this, and it was very important for cultures around the world. And that's like a pretty cool thing, that there are constellations that like are shared among different cultures, right? Because sometimes we think like, oh, people who live on the other side of the world, they don't think like me at all. I don't have anything in common with them. You have so much in common with them. First off, you're made of the same stuff. Pretty obvious. And secondly, there are stories that you have and you share with them from the stars, because ancient people looked at the stars just like we look at the stars. Just like everybody has looked at the stars, because they're there. Hopefully you look at the stars. And so Ursa Major is my absolute favorite constellation, and it's where, if you look at Ursa Major, I can go and point towards where the Big Dipper is, or the Little Dipper in the North Star. I can point towards a star called Arcturus. I can point towards a couple stars in Leo the Lion. It's a really helpful constellation. In fact, here, let me do a little showing right here to show off that, like, if you look right here at Ursa Major, you can see that Ursa Major, these two stars in Ursa Major right here, this is Ursa Major, the bear. These two stars point towards that star, which is Arcturus in Bootes. And these two stars point up there to the Little Dipper and to the North Star. So Arcturus, the North Star, and these two stars down here point to Leo the Lion. And so all this you can find just by finding this, and it's always generally visible, which is pretty great. I can go up here and do the same thing for YouTube. These two stars arc to Arcturus, and these two stars point to the North Star, Doobie and Merak there. And then these stars all down here point to Leo the Lion. And this should tell you, buy this book. It's a really good book. If you buy the paperback version, I don't know where I put the, book cover fell on the ground. If you buy the hardcover version, the cover is a beautiful sky map. Mine has seen way, way better days. Isn't that neat? That should go on a wall. That's a cool wall thing. I think if there's one thing that you might want to try and do while you're at home, while you're with your family, is start learning some constellations. There's a lot of them, and they're very cool. I have this set of playing cards here that have constellations on all the playing cards, so I can play a game where if I want to remember which constellations are, because right now it's cloudy out here in southern Arizona, but if I want to remember, I can go and pull up one and say, aha, Sagittarius, the ten of spades. Sagittarius here is a constellation that I was talking about earlier because it's where the center of the galaxy is. It's where the black hole is. It's Sagittarius A star, and you can see the little teapot there. It's a little teapot. It's short, but it's stout. Anyway, that's a good question. I was happy to answer that question. Okay. Michael Unger asks how the quarantine's affecting astronomers. Well, it's affecting me by making me a little stir crazy. I'm happy to be able to talk with people. Also, most of us are working from home, especially here in Southern Arizona, and we're doing a lot more collaborating over Zoom. So this week is a time where a bunch of prospective graduate students are thinking about maybe coming to the University of Arizona, and so I have to meet with them all tomorrow and Friday over Zoom. I have to talk with them just like I'm talking with you. We've had big meetings and stuff. The big thing is that we want to make sure everyone's healthy and safe, and so we're making sure that people who are working on big projects are working in smaller groups if they are working at a facility like James Webb Space Telescope, which I work on right now. They are trying to make sure that people who are still working on it, and there's a lot of work that's still being done, it's still in the process of being tested, that all that is being done healthy and safe and not, luckily it's a project that is already done in a fairly clean environment. So hopefully we just make sure that people stay clean and don't work in too close of some larger groups. But the larger impacts of coronavirus won't be understood for a little bit of time. But for right now, a lot of astronomers have just moved to working remotely, which, that's how the world's going to work. Okay. Kisley Leonard says, does what happens in space affect us humans emotionally? This is a big question, especially because people are really interested in wondering about astrology, and they want to know the things that happen in space affect us. And the thing is that there's a lot of stuff that we don't understand in astronomy. And so I don't know if I can say from a shadow of a doubt that that won't affect us. I can say that through what we know of in science, the motions of the planets don't affect you gravitationally. They don't give off some sort of light that is different. We do get affected slightly by some of the weird patterns in light in terms of the sun affects us, very obviously, right? We get more daylight, that makes us feel good. And the motion of the moon and the patterns of the moon also seem to affect us if you look at it, large scales. But I can't say, oh, no, don't believe. I think it's really nice to sometimes try to understand what's going on emotionally with you. And if it happens to sync up with something in space, that's fine. That's okay. But I just worry that people might use astrology to limit themselves. And I don't want that. I don't want someone looking at astrology and saying, because Mercury is in retrograde, I can't be friends with you. Because that would be bad. You want to be friends with everybody as much as you can. That's what we have to do in this day and age. Don't limit what you can do and who you might want to be friends with and who you might want to hang out with over Zoom right now or over, live chat or whatever. You want to make sure that you don't use astronomy to limit you or astrology to limit you. But if you want to use it to empower you, go right ahead. Okay. Theodulia asks how many black holes are in space. And I want to make sure that there's a couple other, there's so many good things. So how many black holes are in space? Here's a good thing. So our galaxy has 100 billion stars, 100 billion stars. And we think that generally 1 out of every 100 stars is big enough to form a black hole. 1 out of every 100 stars. Pretty rare. When I was born, both my brother and I were born, we were 10 pounds babies. And that's similar. Stars are born that big, they can form black holes. So if only 1 out of every 100 stars is, and there's 100 billion stars, there's probably something like 1 billion stars in our galaxy. Black holes in our galaxy. 1 billion black holes. And the thing is that there are 100 billion galaxies in the universe. So if there's 1 billion black holes in our galaxy, and every galaxy has, around that, you can do the math. That's quite a bit of black holes. Now you're worried. Okay, black holes sound scary, Kevin. Should I be worried? No! The universe is so empty. Most of space is empty. It's why we call it space and not stuff. Not outer stuff, it's outer space. And the thing is that you have to be okay, you can't be worried about whether or not a black hole is going to fly by, because there's many more things to be worried about. And you should worry about those things instead of black holes. Black holes are relatively not a worry on my mind, even though I study them and care about them a lot. And even though there are 1 billion in our galaxy, there's so many other things in our galaxy. Little rocks and planets and stuff, which is nice. Okay, I think I remember a question from earlier. Okay, I want to get to Laura's question next, which is about planets, but I want to talk about my favorite planet. First off, everyone, I want you to right now tell me what your favorite planet is. Type it in or type it on your phone. I want to see. Everyone put your favorite planet in. I'm going to see also, this will help me see how slow and how much lag there is in my video chat. But this is the time to write in what your favorite planet is, because I have a very specific favorite planet. It's the obvious answer. And while I ask you that, and while you start writing out, okay, we got a Neptune, we got the first person, we got an Earth. Earth's a really good one. My friend David says Earth. Saturn. Oh, Saturn's a really nice one too. Here, there's a really cute pop-up of Saturn here. Saturn's not my favorite, but it's a really good one. Earth, Kepler 42b. Oh man, there's some real nerds in the chat. Good. Saturn, Earth, Pluto. Pluto's not a planet. Pluto's a dwarf planet. We'll talk about that in a second. When I was a little kid, this was one of my favorite books about astronomy. This is the Magic School Bus Explores the Solar System, and they go to my favorite planet. My favorite planet is Mars. Mars is the best planet. Jupiter's, no one said Mars. I've seen no Marses. I'm surprised. Mars is the best planet. It's so great. Earth, really good. Can't go wrong. Earth's a real good question. Good answer. But Mars, my gosh, Mars has polar caps, and it has this canyon on it that is bigger than, it has this thing called the Olympus Mons, which is a canyon that would, if it was on our planet, would stretch, a full canyon, would stretch from New York all the way to Los Angeles. We think the Grand Canyon's nice here in Arizona. It's nothing compared with Valles Marineris. Olympus Mons is a mountain that's actually a dormant volcano that you could stick all of Rhode Island in the top of. It's about the size of Arizona, a whole volcano. Mars has everything. It's got water. The only thing that live on Mars right now, the only life on Mars right now, outside of stuff we may not know of, is robots. No other planet in the solar system has a whole 100% robot population. It's very cool. Mars. Oh, can't get enough of Mars. We've sent robots there, and there's crazy dust storms, and it's cold, and you would not want to live there. If you think living in your house for a couple days or a month in quarantine is bad, Mars is worse. I love it. Mars is the best. That being said, Earth's really good too. It's the one we got. It's a really great planet. Probably the best for us. Wouldn't want to go live on Mars. Earth's pretty good. Saturn has the rings. Rings are a real hit. Venus, not a lot of people say Venus. Venus is pretty good. Venus is really hot. Venus has had what we call runaway greenhouse effect. So it's the hottest planet, even hotter than Mercury, which is closer to the sun. And there's some Neptune fans. Neptune's really good. Neptune's got the highest winds in the solar system, really fast winds. I liked Uranus also as a kid, which is kind of you take a planet and you knock it over on its side, and it's got rings on its side. And I've asked Uranus scientists, how did that happen? How did something knock the rings over on the side? And Uranus scientists go, we don't know. And that's the cool thing about being an astronomer, is that right now we know this tiny amount, and there's so much more to learn. And so if you're sitting out there right now and you're thinking, gosh, I really would love to be an astronomer, but they'll run out of astronomy. We'll never run out of astronomy. There will be astronomy. We'll have astronomy forever, okay? Yeah, David says that no other planet has humans, and David likes humans. David is right to like humans. It's a really good planet. Hey, Ian says Mars. That's good. Also, Jupiter's the biggest planet. That's pretty good too. Jupiter's full of dust storms, swirling storms and stuff. So planets are very, very cool, and people want to know about life on Mars. So getting back to Mars. The thing is right now we've never discovered life on Mars. We know that Mars has water, which is nice. It might be liquid under the surface. Right now there's ices. If you dig out, you can see ices. Mars has a lot of liquid water under the polar caps. And the thing is that we want to know, does that water like maybe contain life? Was there life in the past? And right now we have no evidence saying that that's the case, which is a bummer. When humans go to Mars in the future, if we ever get a chance to go to Mars, maybe we'll do better experiments and really dig under the surface and see fossils of very small microbes. But right now it doesn't look like there was a lot of life on Mars. And maybe if it was a long, long time ago, because Mars is very different now than it was a long time ago. Mars has very little atmosphere. We have an atmosphere, it's what we breathe. Thank goodness we have an atmosphere, it's what we breathe. Mars doesn't have much of an atmosphere because Jupiter kind of harassed it and pulled its atmosphere off over time, and it wasn't massive enough to let the atmosphere to hold on to that atmosphere. So the thing is that Mars, without that atmosphere, gets very cold. And maybe in the past it had an atmosphere and was warmer, and maybe water. We think that there were times when water flowed over the surfaces in lakes or rivers because we see the evidence, like we see the geology, well I guess it's areology, of all of the rivers that don't have water in it anymore. And maybe at that point there was life, but right now, no. Can humans go there? Yes. Do we want to stay there? No, it's very hard. Right now, it's very, very tough because you get very fine dust and the water's not really drinkable right now. And we have a lot of challenges to overcome here on our planet before I want us trying to think we can escape to a planet that would be like living on a place that's worse than Antarctica all the time. Okay, I got a question from Clyde. Clyde wants to know if two black holes ever pull each other into them. And the answer is yes! It happens all the time! It's so cool! People ask this and they think that's a stupid question. Black holes are never... Black holes... Oh! So one of the cool things about galaxies is that galaxies are different than stars. Stars never crash into each other. Planets only rarely crash into each other early on. But black holes and galaxies can crash into each other all the time. Back to the pop-up book. These are pop-ups of two galaxies that are in the process of what we call merging. And galaxy mergers happen and change galaxies all the time. So these are two beautiful spiral galaxies that are on the process of slowly coalescing to form one galaxy. And in the centers of those two galaxies is most likely two black holes. And inside of those two black holes, and inside those galaxies, when those two black holes start to get closer and closer, they'll do what I talked about with those stars at the end of their lives. And they'll slowly coalesce and form a much bigger black hole. And we know this happens because we've observed it, Clyde. Clyde, just in the last couple of years, we've done something we've never been able to do before, which is we've been able to take telescopes that don't look at light, but look at gravity waves. Look at the way that black holes... Uh-oh. Oh no, poor connection. Okay. Clyde, hopefully that didn't break up too much, but we can look at gravity waves. We can look at the way that black holes, as they churn up the universe's gravity, as they collide, because there's so much gravity, they push the gravity around, and those gravity waves move through space. Gravity moving through space like a wave of gravity. And then on the Earth, we can measure that gravity. We can measure it as it slowly causes things to stretch a little tiny bit. It's a very, very small effect, but we can measure it. And we did that a couple years ago. We did that. And we found two black holes colliding. Because what happens is you get the gravity waves and they go like this. Wave, 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 spike. And then this becomes one black hole. And then so you see the waves get really strong and then nothing. It's this, we call it chirp. It's really incredible. And we saw them from two different places at the same time, showing what direction it came from. And like this, we discovered these happen all the time. These are called gravitational wave events. And Clyde, you should go, you or someone that you care about should go look up gravity waves because it's so neat. And you can find videos of the black holes, the simulations of black holes colliding. Theodulia asks, could merging galaxies happen to our galaxy? And the answer is also yes! So, our galaxy is called the Milky Way. Very good galaxy. Pretty classic spiral galaxy. We're one of 100 billion stars. I like Milky Way galaxy. I like Milky Way candy bars. Good one. The question is there any, is there any galaxies that are on a merger course to our galaxy? I wonder. If this, by the way, if this goes off on Instagram, you should just go to the YouTube thing. It's in my bio on my Instagram. You can watch there, hopefully, because that looks like it's also working outside of one little chirp at 121 where I lost data. I apologize. Internet's a dicey thing. So, our galaxy has a nearby galaxy called Andromeda, which is very similar, another spiral galaxy. And if you look at the lines in space they're going towards, they're doing this. And if you looked over time, eventually, they'll collide. And so our galaxy is on a collision course with another galaxy where in billions of years, I don't plan on being around for that, but maybe one of you will, in billions of years, they will also collide and collapse into one giant big galaxy. The thing is maybe you're worried, what's going to happen to the Earth and the Sun? Well, the thing is that nothing's going to happen. By that point, the Sun's probably going to be dead, but we don't want to talk about that right now. That's a bummer. But over time, when galaxies collide, the stars in them don't crash into each other. The stars actually pass right by each other. And you get these beautiful galaxy mergers that create these big balls of gas and like in space, and these big things we end up calling elliptical galaxies. But you should go Google galaxy merger and see this process. You can see pictures of galaxies in the middle of their mergers. It happens all the time. Not just that, but our galaxy has been merging with little tiny galaxies through its entire existence. Oh no! My live video. Let's try another one. No. All right, let's try another one. My live video on Instagram. I'm sorry, everybody. Whoop. All right, okay. All right, I'm sorry, everybody. Hopefully you didn't lose that. Anyway, yeah, Instagram stream seems to have died, but YouTube's still here, right? YouTube's still going. All right, well, maybe people will watch. Okay, a couple people have come back. I'm sorry, Instagram is... I think right now what's going on is that I'm trying to stream in a couple things, and I think my wife is also in a meeting as well. So there's a bunch of streams going out of this one house. But anyway, to finish up, our galaxy, over time, little galaxies have fallen in on it. Little galaxies have fallen in and crashed around our galaxy. And as they've fallen and crashed around, they've left stars in these streams around. This is something that's studied at our university just up the road by some of my friends. By Dr. Gertina Besla, her grad student, Ekta Patel, former grad student, now she's a postdoc. These scientists have all done a really cool job of looking and tracing out and understanding our galaxy by the way that it's interacted with other galaxies over time. Gertina's an expert on our galaxy colliding with the Andromeda galaxy over time. It's going to be a long time from now, but galaxies crash into each other and interact and merge all the time. It's really cool, okay? And so, I really think that, this is... If you're going to look stuff up afterwards, galaxy merger, not just the cool pictures, but really interesting science as well. And since the 70s, astronomers have studied it. And there's actually software you can probably download where you can take two galaxies and crash to each other and watch all the stars get thrown around. All right, here's the big question. Eleanor and Clyde want to know, and my friend Lauren kind of joked with me earlier, why isn't Pluto a planet anymore? So, in this book... this is a version of the book that was written, not my childhood, but in this book, when I was a kid, Pluto was listed as a planet. And I bet in this book, if you were to go look, you'd find Pluto is written as a planet because it's from 1985. But between the 80s and now, some astronomers got together and they started thinking about planets. And the thing is that they started looking out. So Pluto was discovered in the 1950s, by a guy named Clyde Tombaugh, who's a Kansas farm boy. And Clyde Tombaugh was this really interesting scientist who was brought out to Arizona, to Flagstaff, to look for a planet out at the edge of our solar system. That was his job. His job was, I want you to find this thing. And he had to do this planet. A guy named Vestos Slifer hired him. And he looked every night by taking a picture of the sky or picture of the sky, and then the next day during the day, he would take those pictures and look at the same picture he took a year ago or half a year ago or a month ago and look and see if anything moved in them. Because stars will stay the same, but if there's anything else that they might, it might move a little bit. And he started looking to see if anything moved, and if he saw something that moved, aha! It took him a long time to do this. He used this thing called a blink comparator, which is you have to blink the images back and forth and look for the thing that moves and go, there's the planet. And he finally found this object. It was very exciting. And it was named by a young girl who, in a naming contest, named it Pluto. Pretty cool. Everyone loved it. All-American story. We found this planet. But then over time, a bunch of astronomers started noticing, Pluto's not alone out there. There's a bunch of other objects. And they started getting all these objects, and those objects weren't called planets. So it seemed a little unfair. It seems a little unfair to Pluto to be like, well, I just was discovered first. And then a bunch of other ones are like, well, I have equal. It'd be like, so I have a younger brother named Robert. Imagine if my parents had me and were like, that's our son. And then they had Robert and they were like, you're also here. That wouldn't be fair to Robert. Robert's a son as well. So so the astronomers got together and said, okay, we're finding a lot of objects that are like Pluto, big planet-like objects out there. Maybe we need to change what we mean by planet. Uh-oh. And so what they did was they convened a meeting and they said, what are the rules to become a planet? And here are the rules. Rule number 1, you have to go around a star. Which means our moon, not a planet. It does go around the star, but it also mostly goes around us. Our moon, not a planet. Doesn't satisfy the first rule. Rule number 2. It has to have a circular orbit. Which means that comets, which these crazy oval orbits, don't satisfy it. Sorry, comets, you're not planets. And number 3, and this is the one that really kicked Pluto out of the club. Sorry, Pluto. My brother's watching now. You're not a sun, you're a planet. Number 3 is that planets have to actually what we call clear their orbit, meaning that over time, in the orbit around the sun, planets can't be in the same line as other objects around there. And Pluto has a bunch of objects that are also in the same orbit, right? Jupiter, Earth, is the big planet on campus. Anyone gets in its way, it just kicks them out of its way. And so its orbit is pretty much cleared all around. It's empty. There's some little rocks and stuff, but the planet is mostly there. Jupiter has little rocks around that kind of follow it around like groupies, but that's just because it's so big. But Pluto did not do this. It didn't clear its orbit. And because Pluto didn't clear its orbit, essentially what they did was they said, actually, neither Kevin nor Robert are sons. They're dwarf sons. Neither Pluto, nor Eris, nor Makemake, nor Haumea, neither of these are planets. None of these are planets out there. They're dwarf planets, which means they're part of an even cooler club, the Dwarf Planet Club. And so that is how this was done. And it caused a lot of uproar because people like Pluto a lot. I happen to like Pluto a lot. And in fact, what's funny is that we sent a spacecraft up towards Pluto to go take pictures of it, and then it was declared a dwarf planet, and then we were like, well, now we're still taking pictures of it. And the pictures came back, and they were incredible. I was teaching a class in the solar system when this happened, and if you've not gone to look at the pictures of Pluto, they're some of the coolest pictures you can see, because it's like a spacecraft looking at this object, and it has all sorts of structure on the surface, and like it has these ices, and it has these canyons. It's really incredible. And that happened because we sent a spacecraft there to take pictures of it. And then it went on farther to look at other objects out there. That whole group of objects way outside of our solar system, we call that the Kuiper Belt. And it was named after an astronomer named Gerard Kuiper, who was here at the University of Arizona. The building's named after him. Gerard Kuiper proposed this idea, had some theories about this idea, and it was discovered years and years later in the 90s by some astronomers at UCLA. 2 astronomers at UCLA discovered the first Kuiper Belt objects. And now we know of a bunch of Kuiper Belt objects, and Pluto is one of the largest of them, and its moon Charon and stuff. So that's why Pluto's not a planet. Sorry. I like Pluto too. Pluto's a nice one. Okay. Now, more questions. I think I've got another 10 minutes. My voice is running out. Are there ice volcanoes? Oh my gosh. That is an interesting question. And the answer is yes. On moons in our solar system, we've found volcanoes that are not really volcanoes in that volcanoes are defined by their magma, but they're like essentially places where water ice has kind of squished out and formed these things on, like, so you can look at the moon Europa, and Europa is like mostly ice on its surface, and we can look at cracks between these plates of ice that are kind of floating around and see these things where ice is spurted up out. And so that is the best way to describe an ice volcano, My brother asks, my brother's fiance asks, if the spaghettification happened so fast you would not know, then how are we able to see that or know about that? Well, the thing is that it's mostly theoretical. We just in mathematical terms, we go, okay, well, this is what would happen. And in math terms, we can do on any time scale we want. So in math terms, we can say, most of this is all theoretical. We've only taken pictures of black holes in two ways. One, we've taken the pictures of the disks around them from far away, so they just appear like a bright light source. And two, just last year, we took pictures of the gas actually falling onto one black hole. And that was a really cool result. That was a global team of researchers, including many people at the University of Arizona. University of Arizona, very good astronomy department. But otherwise, we haven't actually watched this happen to, a person hasn't fallen into a black hole, but it's all theoretical. And it most likely would happen because that's just how gravity works. Clyde wants to know, how old is Jupiter? Good question, Clyde. The thing is, Jupiter is as old as the Earth. It's as old as Mars. All the planets were made about the same time, which was when the sun was made, about 4.5 billion years ago. 4.5 billion years ago. 4,500,000,000 years. A long time. Pretty, about a third way back to the beginning of the universe. And this is like when the sun was made, it was made from a big gas cloud that collapsed down, and in the center formed a star. And then, just like I was talking about the ice skater pulling their arms in, the gas cloud starts to spiral in, become a disk as well. And in that disk, with the star in the very center, the sun being formed, from that disk, little planets started to be made at the same time. All the planets that you know of. And the leftover bits form the Kuiper Belt objects that I was just talking about. And so you get all of these planets at the same time. So that's why Jupiter is the same age as the Earth, as Moon. And we can go and look and actually take, like when we went to the moon, we got rocks, moon rocks, right? You can touch one. If you go to Washington, D.C., you can touch a moon rock at the Smithsonian. And we can measure the age of those rocks and find out, same age as the oldest rocks we see on our planet. When we found Mars rocks too. How do you find a Mars rock if you haven't gone to Mars? Well, here's a cool thing. Mars rocks happen because an asteroid or like a meteorite will crash into Mars and knock a chunk of Mars off into space. That chunk of Mars will fly off through space and land on our planet, and we'll find it in the desert somewhere and go, this is a weird rock. And if you do some analysis on it, you find this rock is way different from any rock that we've seen here on Earth. And you realize it has the same composition as what we've seen when we look at pictures of Mars. It's a Mars rock. And there's Mars rocks, and you can take pictures, you can take analyze Mars rocks and look at how old those are. Same age as the oldest rocks on the Earth. So we know that most of the planets are the same age, 4.5 billion years. Question from Angela. What's the most interesting discovery in space that yet can't be explained by science? So, this is a big question. And I think there are a couple astronomers who are in the chat. I've seen them sneakily sneak in, and they probably have their own answers. So I got to think about this myself. The thing is the vast majority of science we don't understand. The vast majority of astronomy. We make discoveries all the time. We don't actually know what's going on. That's a scary thing. We have some ideas, but it's a scary thing. And let me try and think of what the most interesting discovery that can't be explained by science right now. There are these signals sometimes that we get from space. These like strange radio signals, and we have no idea what they are. Like these weird signals where we just for a little tiny bit, there was a really incredible burst of radio waves from one part of the sky, and we'd never seen that again. And we go, is it aliens? What could it be? What could make something that energetic? That's pretty crazy, right? Brian Toomey brings up a really good point. That's actually you're right, Brian. Thanks for helping me out on a jam, Brian. Brian brings up Oumuamua. So 2 years ago, 3 years ago, last year, 2 years ago, there was this rock that just came in through our solar system. It just went right by the sun. If my head's the sun, it was like this. That's all. And as it came through, it was like a big long tube we discovered, like a rock tube. And we saw it and it left, and we got the best data we could, but we have no idea what it was or why it was like that or how often rocks like that happen. And the thing is that we won't ever know about that because it'll just keep going off. It's too faint for us to see anymore. Look it up, Oumuamua. What is it? Why is it like that? We had a person come and talk all about the science they did. Looking at light, analyzing, understanding why we think it's the shape it is. And there's some ideas, but you have to do a lot of math to figure out why a rock, it'd have to be spinning in order to get like that in a way that we just didn't expect that rocks from space could be. And there's a famous book called Rendezvous with Rama by Ursa Clarke that's kind of like, what if a spacecraft did that? Like in actual space, like a big cylinder space thing. So a lot of science fiction nerds were like, this is so cool. And like astronomers were very cool. But Oumuamua, that's one of the most interesting things that hasn't been explained by science. Google it. It's pretty interesting. I think Izzy asked, how was Mars made? Or maybe Anna asked, how was Mars made? Mars was made in the very same way that the Earth was made, in that it was, well, there's some discussion about whether or not Mars was made by putting together a lot of bits and pieces, or whether big things became, like big rock things came and cracked to make smaller ones. But generally we think that most likely, if you start in the gas cloud of the solar system making the planets, you start by taking little bits of dust and pushing them together. They'll have a little more grabbing power, gravitationally and electrochemically, to grab on other pieces. And slowly you start making little rocks into boulders, and those boulders collide to make larger ones. And for Mars, what probably happened was Mars was trying to be made bigger and bigger, but Mars was proximate to Jupiter, and Jupiter unfortunately is really massive, and so Jupiter probably made it so that Mars wasn't allowed to be larger than it was. And so early on in Mars' history, instead of it getting larger and larger to be like our Earth, the other stuff that would make it formed partially the asteroid belt and went off into the other parts of the solar system. And so Mars is a little bit runty compared to what it should be. It was probably molten maybe earlier on, because that big canyon I was telling you about, Valles Marineris, looks like it might be two tectonic plates like on our planet that are sliding against each other, but it's not super well known. But that's how we think Mars was made. Katie wants to know if there are other Earth-type planets in other galaxies. And undoubtedly, yes, but we haven't discovered them yet. The thing is that uncovering planets outside of our solar system is really tough. My office mate is a guy named Thomas. And that's what he spent his career doing, is looking for other planets. And the thing is that you can only do that. The techniques that he uses are only good in our own little neighborhood. It'd be like saying, are there people in other countries? And all you ever know about is there's people on your block, or people who live in your house. It'd be like saying, are there people in other countries? And all I know of is my wife and my cat. Can anyone see the cat there? Hopefully you can see the cat there. And that's a thing that's like a bummer, because we know there's people that live in our, there's like planets like our Earth in our solar system. There's one. And the thing is that we're discovering better and better maybe planets that like could be like Earth, that are in our solar neighborhood of stars. But it's very hard because planets are really faint compared with the stars they're around. So they're like, I have this light here. And if I put this light, it's not even that bright. If I need a better light. Here we go. I have this light here. Boop. All right, so for the people on... Okay, so this is our sun. Now imagine if I had something that was like really, really tiny right next to it. It'd be very, very hard to see that because all you can see is the sun. All you see here is the sun, right? And so if this is all you can see, you can't see any little planets around it because the sun's so bright. And that's annoying if you're a scientist trying to find planets, because it's really, you have to find them by being very clever, looking for the way they pull the star as it moves around. Yeah, there, that's good. Now the YouTube folks can see. You can't, it's hard to see, right? Pretty hard to see. Bad idea to shoot your red LED at your camera. But undoubtedly have to be there because we know that planets are so common. When we get the techniques to find them, we find planets everywhere. And the thing is they have to be in other galaxies. But they're so far away that I don't know if we'll be able to find them or talk to the aliens that might live there. But I think that hopefully in our lifetimes, maybe we will find planets that are like our planet. Maybe with life like our planet. That'd be really cool. I would like that. Maybe we can talk with them and ask them how they solve problems. All right, guys, it's almost an hour. And I want to finish by talking about books. I want to tell you, if you're home and you want to get some books, go to a website for your local bookstore and see if they'll get books for you and have them shipped to you. This is a really good book. Magic School Bus Explores the Solar System. Really good for your kids. I said H.A. Ray the Stars, A New Way to See Them. This is the book that you should have on your bookshelf as a book to learn the constellations because it's so well written and it's so beautiful. Look at all these beautiful drawings of constellations. Look at Virgo right there. Oh, Virgo, you're such a good constellation. I'm a Virgo, in case you guys wanted to know what my astrological sign was. If you like comics, I know this guy John Chad. This is Leo Geo and the Cosmic Crisis. It's pretty cool. It's also neat in that it's actually also Matt Data and the Cosmic Crisis. Halfway through the book, you have to flip it over. And it's a really cool book. That's one of these books I loved as a kid where you just got like a bunch of things to read and look at. Every single part of the book is really neat. And if you're an adult and want to read something about a really cool astronomer, this is Miss Leavitt's Stars by George Johnson. And it's about Henrietta Swan Leavitt, who is the person who discovered a type of star called the Cepheid variable. And the stars that she discovered allow us to understand that the universe was expanding. And if you've not ever heard about Henrietta Swan Leavitt, she's the best. Very cool astronomer. She was hired as a computer. Okay? So you should read about her. She's a really cool astronomer. There's a bunch of really cool astronomers that have existed and lived, especially lady astronomers. My boss is Marsha Ricci. Look her up. She's really cool. And look up James Webb Space Telescope. Okay, it's 2 o'clock. I am exhausted and I have to go do a bunch of work. But you guys were wonderful and I appreciate all the questions. And if you have more questions, you can follow me on Instagram, Kevin Hainline. That's my name. And just send me direct messages and I can answer them. And hopefully in the next couple of weeks, I can do another one of these. Maybe one where it's only on YouTube and I can use my green screen that I have that I didn't use for Instagram. And I can show you guys some stuff in space because I can use this really cool piece of software to fly through space, which would be kind of fun. Okay? But you guys, this was wonderful. Everybody, have a nice day and study astronomy and be good and wash your hands a whole bunch. 20 seconds. You know what's a really good 20-second song to sing? If you sing it slowly, Twinkle, Twinkle, Little Star. Sing the whole thing. It's 20 seconds. It's kind of on brand for me. All right. Bye, everyone. You're all wonderful. Bye. Bye. I love you all. Bye. Boo-doo-boo-boop.